Alright, this video is meant for my geometry students. We have a test either on Monday or Tuesday, depending on what day you have me. And this is a review of sections 4 and 5. Remember, there is a sections 1 through 3 review already posted on YouTube. I would suggest you watch them both. Alright, here we go. Section 4. Number 1. Write a similarity statement relating the 3 triangles in the diagram. So, recall, in these problems, you have the big right triangle with an altitude drawn. Well, in the big right triangle, label the other 2 acute angles with 1 and 2 markings. So the 3 triangles are all similar. So in this triangle JKN, there's a right angle, there's a single mark. So this angle right here is a double marked angle. That would then force in this smaller triangle, double marked, this is the right angle, here's a single marked angle right here. So now I can easily find the triangle similarity. The big triangle, I will name triangle JKL in alphabetic order. So JKL is single to right angle to double. So I need to follow that same correspondence in the other 2 triangles. So in the medium triangle, single, J, to right angle, N, to double, K. And then in the small right triangle, single, K, to right angle, N, to double, L. So again, single, right angle, double, single, right angle, double, single, right angle, double in all 3 triangles. And there's a similarity. Here's our next problem. We will solve for x and y. And in these problems, we're going to use geometric mean. So first thing I will do is I will say, okay, where is x? X is a leg of this triangle. Alright, so I'm going to use the leg geometric mean idea, which states the hypotenuse over the leg is equal to the leg over the adjacent hypotenuse part. Alright, so this is the idea I will use. The hypotenuse is here. Goes all the way across. 21 plus 4, 25. So my hypotenuse is 25 in this problem. The leg is x. The leg is x. And the adjacent hypotenuse part, if this is x, the part of the hypotenuse that touches x is this 4. I will cross multiply x times x is x squared. I want this in simplified radical form, so I will not multiply 4 and 25. I will then take the square root of both sides, and I will talk about 4 and 25. 4 is 2 squared, and 25 is 5 squared. So over here, the square root and square root cancel, there's x. And underneath this radical, I have now 2 squared times 5 squared. Well, the 2 and the 5 come out because they're each squared. There's nothing left inside the radical, so I just do 2 times 5, which is 10. And there's x in this problem. Now, to find y. Y is the altitude. So we have to use the altitude idea, which is hypotenuse part 1 over the altitude equals the altitude over hypotenuse part 2. And I fill in the hypotenuse parts are 21 and 4. So 21 over the altitude is y equals the altitude is y over the other hypotenuse part, which is 4. I will cross multiply y, and y is y squared. I will not multiply 21 times 4 because I want simplified radical form. I will take the square root of both sides. I get y on this side. Over here, 21 can be written as 3 times 7. Those aren't perfect squares. 4 can be written as 2 squared. So now we have, right down here, y equals the square root of, so 3 times 7, they're not perfect squares. So since 3 and 7 are perfect squares, they just stay inside the radical. The 2 pops out though. And if the 3 and 7 stay inside the radical, you multiply them out, 21. And there's the value of y. Okay, so we're going to find the geometric mean between these 2 numbers of 3 and 4. So remember, it's as simple as x equals the square root of a times b. Right? The square root of the product of the numbers. X equals the square root of 3 times 16. And again, 3 is just 3. 16 can be written as 4 squared. So this is what x is. Anything that is squared comes out. The 4 comes out. The 3 is not squared, so it's left inside. And there's the geometric mean. Okay, I like this problem. It says to estimate the height of a stone figure. Anya holds a small square up to her eyes and walks backwards from the figure. She stops when the bottom of the figure lines with the bottom edge of the square, and the top edge of the figure lines with the top edge of the square. Her eye level is 1.4 meters from the ground. She is 3.5 meters from the figure. What is the height to the nearest hundredth of a meter? Alright, it's a kind of cool problem, okay? So the idea is, you're standing here with like this square, so you have a square angle here, and you've stopped when the figure is in the bottom and top of this square. So you have a right triangle. And the idea is, what is this height from here to here? That's what you want to find. Well, notice where your things are. This 1.8, that's a hypotenuse part. And this 3.5, that is the altitude. So I think this is an altitude problem. Now for the altitude, remember you need, and I'll do it down here in green, you need hypotenuse part 1 over the altitude equals the altitude over hypotenuse part 2. So if I look at my picture, I have one hypotenuse part, 1.84, but I don't have the other one. I'm going to call that x. Okay? So we're going to find x first, and then once we find x, to find the height h, we're going to add x in this 1.84. But first, find x. So the hypotenuse part 1 is x over the altitude, which is 3.50. That equals the altitude 3.50 over the other hypotenuse part, which is 1.84. We're going to cross multiply, and we'll get 1.84x equals 12.25. And then we'll divide by 1.84. And we get, we're going to round to 2 decimal places, so x is 6.66, and that's in meters. So to find the height, we're going to take 6.66 and add it to 1.84. So 6.66 plus 1.84 gives me 8.50 meters. And there's the height of this stone statue. Here's our last problem from this section. So we got to find x here. So if I look, where are x? Well, 12 is the hypotenuse. So that means x is a hypotenuse part. And x plus 3 is a leg of the big triangle. So we're probably going to use the leg idea here. And to recall what the leg idea is, it is the entire hypotenuse over the leg equals the leg over the adjacent hypotenuse part. So what is the hypotenuse? Well, it's 12 over the leg, which is x plus 3, equals the leg x plus 3 over, and now the adjacent hypotenuse part is right here, x. Right, it's the one next to x plus 3. Now I see some binomials, so I'll put them in parentheses, and we cross multiply. 12x equals x plus 3 times x plus 3. This requires us to FOIL. So on this side, we got to do first, outer, inner, last. So 12x equals first, x squared, outer, 3x, positive 3x, inner, positive 3x, last, positive 9. 12x equals x squared, combine your middle terms, plus 6x plus 9. Now, when you have x squareds and x's, you need to subtract 12x here so that one side becomes 0. So I'm going to bring that over here. So we get 0 equals, the 12x's cancel, x squared. This is minus 6x plus 9. And now this is a quadratic. We need to solve this by finding the factors of c. There's no a, so just c matters. 9. So 1 and 9. Now, since c is positive, your signs will be the same. And since b is negative, those two signs will be negative signs. So our factors have negative signs. That's negative 10. Not going to work. 2 does not go to 9. 3 and 3. There we go. Magic numbers. Boom. Minus 3, minus 3. In my parentheses, x minus 3, x minus 3. They equal 0. Scroll down for a sec. So set each one equal to 0 and solve. Add 3. X equals 3. Add 3. you get the same answer, x equals 3. So that's the answer, x equals 3. Another quadratic, great example. With these quadratics, make sure you just remember, it's just foiling in reverse, right? So you're always looking for two sets of parentheses that can multiply to get that quadratic. So just think about that as you factor. Okay, so here we go. Solve for x here. This is the corollary to the side splitter. I'm just going to write side splitter. Again, because this is not a triangle, it's just two transversals and three parallel lines. But still, the parallel lines split these transversals into proportional segments. So here's x. I need to know what this is right here. Well, if this entire thing's 11, and that's x, then this part right here is 11 minus x. And now I'm in business because I can fill in my proportion. X over, now, work up the transversal. X over 11 minus x equals. Now, you go back to where x is and jump across. 4 over, and work up the transversal. 9. This is a binomial. I'll put in parentheses. 9x equals 4 times 11 minus x. We'll distribute the 4. 9x equals 44 minus 4x. I will combine my x's by adding 4x to both sides. 13x equals 44, and we'll divide by 13. That does not simplify, so that's a good answer. 44 13ths. And that's the value of x in this problem. Alright, let's take a look at this problem here. We have a triangle, and we have an angle bisector. So this is going to be the triangle angle bisector theorem. Alright, so in this picture, the angle bisector splits this side into proportional segments with the sides at the angles. So here's x. Now, I'm going to work across the angle bisector. So if this is x, I need to go across, right? This is the angle I'll extend the angle bisector. Oh, that's bad. This is 6, so I'm going to extend the angle bisector. So I'm going to jump across the angle bisector along this side. Now, I don't know what this is. Well, if that entire thing is 6 and that's x, then that right there is 6 minus x. And now I do. Now, I'll jump back over to the side with x, go to the angle, the side of the angle 6, over, and jump across the angle bisector 4. Right, so this is the angle bisector, and I like to work on left, right, left, right. Here we go. Binomial, put in parentheses. 4x equals 6 times 6 minus x. Distribute the 6. 4x equals 36 minus 6x. Add your 6x to both sides. 10x equals 36. Divide by 10. X is 3.6. You could also simplify if you wanted to the fraction, but it doesn't matter. Okay, here's the next two problems. We're going to fill in these proportions, and you'll have something like this on your test, so I just wanted to go over it. So PT, so I drew two separate figures so I could mark on them. So PT is here, over something, equals TQ, so TQ is here, over KQ. Alright. Well, notice the parts. This is that triangle angle bisector idea. Here's the angle bisector. Now, what they've done is they kind of separated the things because I said let's go across, so PT over TQ. What I would say is PT over TQ equals, and then I'd come back here, and that missing side is KP over KQ. So TP over TQ is KP over KQ. That's how I would do this one with this angle bisector idea. But they switched our means. Notice PT and KQ are in the same spots, but their TQ went up here. So what is that missing length? KP. Over here, let's see. KP, I don't know, LQ and KQ. So here's what they're doing. They're using the side splitter. Right? So they have the K is the separation. So they have KP here. Alright? And then they have LQ and KQ. So they're working down the transversal here. LQ, KQ, so you got to go across to LQ, and it's MP. This is the missing side. MP. because then that would work up the transversal MP, KP. And there you go. Side splitter idea. Okay, 2 more problems. Number 9, solve for x. This is the side splitter idea. So let's start with 7x. Work up the transversal over 12 equals, go back to 7x. 5x minus 1. Work up the side, 2x plus 2. These are binomials, so put them in parentheses. 7x times 2x plus 2 equals 12 times 5x minus 1. Distribute on both sides. 14x squared plus 14x equals 60x minus 12. Now I have x's and x squareds. Move everything to one side. Let's bring the 60x over. And let's bring the 12 over. Now notice I put the 12 out here because there's no numbers. They all have x's, so the 12 will not combine with anything. I'll put the 14x squared first. 14x minus 60x is negative 46x, and the plus 12 comes down. These cancel, and there's 0 on that side. Okay, I'm going to scroll down. So now, here's my quadratic. First thing I'll do, since there's an a value, common factor. And that common factor is 2. Divide everything by 2. Make the numbers smaller. And now, when you have an a and a c value, I'm going to come over here, you need to work with the factors of a and c. So the factors of a are 1 and 7. That's a great number because it's prime. You know you have to use 1 and 7. But 6 has 2 sets of factors, 1 and 6 and 2 and 3. So when I get my 2 parentheses, I know that 1 and 7 have to go here and here because they have to make 7. And they each get an x. But I don't know which c's go in these spots. Now what about the signs? Well, c is positive. That means the same signs. And since b is negative, they're both going to be negative. So it makes it a little easier since I can just put minus, minus. They're both the same. Now, I want to get 23. Well, I think that if I match the 2, the 2 with the 1 and the 3 with the 7, that means the outer and inner terms. So the 7 gets the 3 and the 1 gets the 2. Let me check that real fast. Alright, if I were to FOIL it back out, I would get 7x squared minus 2x. 7x squared minus 2x minus 21x plus 6. 7x squared minus 23x plus 6. Notice I get what I started with right here. So these are the correct factors. So again, your outer and inner terms have to combine to get 23. You knew you had to use 1 and 7 as your a factors. So your choice was 1 and 6 or 2 and 3 for your c. And again, I knew that 3 times 7 was 21, which is close to 23. So now over here, I'm going to take each factor, set it equal to 0. X minus 3 equals 0. 7x minus 2 equals 0. Let's add 3. X equals 3. Over here, let's add 2. 7x equals 2. Divide by 7. X equals 2 sevenths. And because it is positive, they're both positive. You'll get positive lengths. Life is good. Both are possible answers. 3 or 2 sevenths. So again, another factoring, another quadratic. All right, last problem here. I have an angle bisector of a triangle. Separates the opposite side into segments 5 centimeters and 3 centimeters long. So here's my angle bisector. So there's my angle being bisected. 3 centimeters and 5 centimeters long. A second side of the triangle is 7.5 centimeters long. Find all possible lengths for the third side. Well, they don't tell me which side is 7.5, just a second side. So I have choice. This side could be 7.5 centimeters, which that would be x. Or this side could be 7.5 centimeters, and this could be our unknown, call it y. So we have 2 lengths to find. Okay, let's start with this, the red. Now again, this is the triangle angle bisector theorem. Okay. So if I start with x, the red, x over. Now I'm going to jump across the angle bisector. This is my angle bisector. So I'm going to jump across. X is the side of the angle, so 7.5 is the side of the angle. Come back across the angle bisector. Go down that third side. 5/3. Cross multiply. 3x equals 37.5. Divide by 3. And we get x equals 12.5. And that's centimeters. So that's our first length, 12.5 centimeters. Or we could be the blue. Y over, now again, jump across the angle bisector, 7.5, equals, come back to the side with y, go down that separated side, 3/5. 5y equals 22.5, divide by 5, y equals 4.5. And that again is in centimeters. And here are the two possible lengths for that third side using the triangle angle bisector theorem. Okay, hopefully these 10 problems helped and you feel confident coming in to your test either Monday or Tuesday. Thanks for watching.